Check it.
Okay, welcome back. Today we're going to be talking about piecewise functions, how to graph them, how to evaluate them. This is section 2.1 in the Glencoe textbook, but if you're in the McDougall-Littell textbook, it's 2.7, which is this one right here. So if you're in the Glencoe, it's 2.6, otherwise it's 2.7. Now, what is a piecewise function? A piecewise function is a function that when you look at it on a graph has distinct pieces, separate pieces. So instead of having, like, for instance, one single parabola here or one single line, what we have here is a function that consists of three pieces. The first piece is a ray. You guys remember what a ray is? A ray is a line that ends at one point. Okay, now we read our graphs from left to right. So even though the arrow is pointing to the left, we're not going to the left, we're going to the right always. So coming from the left, this ray stops here at x equals 2. Then it jumps to a different line. This is an entirely different line down here. There's a line segment from -2 to +3 here. Then at +3, it jumps to a third function, which is this line here, actually a ray, going this way. Okay, so this has a different slope than this, and this has a different slope than this. It's three distinct lines. Well, actually, technically it's two rays and a line segment, but three pieces. And that's what a piecewise function is. And we're going to be graphing these. But before we graph them, let's do a little practice here. Let's remember how to graph a line from Algebra 1. I've set up a couple of warm-up problems here. Sketch the graph of y equals 2x minus 3. Okay, so if you remember from Algebra 1, this is what you call a y equals mx plus b equation. And it's the equation of a line. Okay? And in y equals mx plus b, the m stands for slope. And slope, if you remember, is rise over run. So in this case, your slope, the thing that's in the m spot, is 2. But what's the run then? Well, put it over 1 so that you can have your rise over run. If your slope is a whole number, you should make it a fraction, put it over 1. Now your b, if you remember, is your y-intercept. Y-intercept is where on the y-axis you are when x is 0. So if you think about it, if you plug in a 0 for x here, this whole thing turns into a 0, basically disappears, and whatever you have here for b is your y-intercept. Okay? So your b in this case is -3, your y-intercept, -3. So let's come over here. We're going to graph y equals 2x minus 3. We said that our y-intercept is -3, so that means our y-intercept is right here. And we said our slope, our rise over run, was 2 over 1. So from this starting point, you go up 2, that's your rise, up 2, and run 1. So up 2 over 1, up 2 over 1, up 2 over 1, just keep doing that. And now when you want to go to the left, now I just said that you always go to the right with a function because we read graphs from left to right like we read English. But the fact is sometimes you have to go to the left. So if you go to the left, everything is backwards. So instead of up 2 over 1, it's down 2 back 1. And you have this here. So now we have a line. So we just draw a line, connect the dots here. Go from here to here. Number 2, sketch the graph of y equals 2x minus 3. So same line, but this time only for -1 is less than x, less than or equal to x, less than or equal to 2. Now from the last lesson, we talked about three-part inequalities. And we're saying here is that we only want this line where the x is between -1 and +2. And because these are underlined, these will both be closed circles. So that means it's the same line, but we only want it to exist between -1 and +2. So how can we do that? Well, one thing we can do is just say, all right, well, we already have the line here. Just cross out the parts of the line that are outside of the range that we don't want, or the range that we want. So that would do the trick. Okay? And there it is. This would be, okay, y equals 2x minus 3 with the domain constraint of -1 less than or equal to x less than or equal to +2. That would be it. And you can see that's a line segment like we saw in the piecewise functions. This could be one piece of a piecewise function. But it seems like a sloppy way to get to that piece to draw the entire line and then go back and scribble out parts of it. So what's a better way to do this? How could you do what I just did in question 2? How could I do that without doing question 1 first, without drawing the entire line? And the answer is, what you can do is find the endpoints of the line segment and then connect the dots. So what I mean is this. Look at your function, y equals 2x minus 3. We could graph the entire thing like we did in problem number 1, but we don't want to scratch it out like we did in problem number 2. So we're going to take problem number 2, and what we're going to do is find the endpoint. So take the -1, which is your starting x value, and evaluate it by plugging it into the function here. Evaluate means plug in and see what value you get. Okay, it's not solving. Solving is getting x by itself. Evaluating is plug in and see what you get. So let's evaluate what we get for y if we plug in -1 for x. Well, 2 times -1 is -2, minus 3 is -5. So what I see here is that when x is -1, y is -5, and that's going to be one of my points, one of my endpoints. Now, because this is underlined, it's going to be a closed circle, not an open circle. So I'm going to come down here, -1, comma 1, 2, 3, 4, 5. That's right there. Closed circle. Now, where's the other point? Well, there's a second x value here. Plug that in and see where we land here. So 2 plugged in, evaluated here. 2 times 2 is 4, and 4 minus 3 is 1. So 2 comma 1 would be right here. Also closed circle because it's underlined. Okay, and now we take our ruler and connect the dots. And there you go. That is the same thing, but we did it without the scratch out method. Okay. All right, this last one. Can you sketch the same line again? Y equals 2x minus 3 for x is less than 3 only. So this time I'm not giving you 2 endpoints. I'm only giving you 1 endpoint. And what do you call a line with only 1 endpoint? It's called a ray. So once again, we're going to do the same thing here. We're going to find that endpoint. Take the 3 and plug it in here. Okay, so that means our x value is 3, and the question is, well, what's our y value? So we'll find that out by plugging this in. And 2 times 3 is 6, and 6 minus 3 is 3. So 3 comma 3. And this is not underlined, so it's going to be an open circle. So let's put that on here. 3 comma 3 is here, open circle. And here's the thing now. We want to go, which direction do we want to go in? We want to go to the left because it says less than. So we already know what this line looks like. We're drawing the same line 3 times here. 1, 2, and this is going to be, this is the line right here. Oops, actually, not very well drawn. Something like that, right? So, but we only want the part that's going this way. We don't want this over here. Okay, but once again, we don't want to do the scratch out method. So let me not do it that way. Here's my starting point. I know I'm going to the left because it's less than. I know my slope is what? My slope is 2 over 1. So if I were going to the right, I'd be going up 2 over 1, up 2 over 1, up 2 over 1. But since I'm going to the left, I'm going to go down 2, back 1, down 2, back 1, etc. Down 2, back 1, down 2, back 1. Okay, until I reach the end of my graph, which you should always do. Go to the edge of your graph. And now, there it is. So y equals mx plus b for all 3 of these. However, for one, you had, well, actually, let me erase the scratch out stuff here. You had the entire line. Here, we had domain constraints, which made it into a line segment because we had 2 endpoints. And here I only gave you 1 endpoint and a direction. And that's what you need for array. And there you go, little review of how to graph y equals mx plus b lines, line segments, and rays from Algebra 1. Let's do one more thing. Let's talk about one more thing that we need to talk about before we get into piecewise functions. Now, piecewise functions, like I showed you in the picture at the beginning, are separate functions that share the same graph. So we saw something that looked like we had a ray, and then we had like a line, a horizontal line segment, for instance, and then we had like another ray, something like that. We could very well have had a ray, a parabola, for instance, another ray, okay? Or we could have a ray, a parabola, and a square root function, okay? It doesn't have to be linear, but we're gonna stick to linear for the, for the first lesson here especially. So one of the things you have to understand is that you can't have a line a parabola, and a square root function all in the same graph, because what happens here is you're violating something that you learned in Algebra 1 called the vertical line test. And the vertical line test says that if you draw a vertical line down on any function, that you cannot hit it more than once. Okay? And you can see, like right now, I'm only hitting the blue in one place. Okay? But if I drag it over here, for instance, now I'm hitting the blue in two places. I'm hitting it here and I'm hitting it here. Now, what does that mean? That means for one x value, whatever this x value is, I'm hitting two different y's, and that's not possible with a function. You can only have one x for one y. So this fails the vertical line test because I can hit the function more than once going down. So this is not a function. This is, quite frankly, this is a mess. So when you do a piecewise function, you have to make sure it still passes the vertical line test. You have to make sure that you don't have any of this overlapping. Okay, so let me try a different function and see if this passes the vertical line test. Let me try a, I don't know, what would be a reverse square root function, for instance. An absolute value function starting from here. Okay. And then, I don't know, part of a parabola. If I took my vertical line, can I hit this more than once going straight up and down? The answer is no, 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 that's only once. How about right here? Right here, it looks like I'm hitting twice. But the fact is, this is an open circle and this is a closed circle. So I'm actually only hitting once. The open circle doesn't count. Okay, it's an empty space. So I'm actually not hitting twice here, even though it looks like I am. Okay, grab the line here. How about here? That's all good. This is all good. That's only 1 point there. That's only 1 point there. Okay, so this passes the vertical line test. Pass. And if it passes the vertical line test, that means, yes, this is a valid function. This is a function. Okay? And that's a little quick review of the vertical line test from Algebra 1. You can only hit a function one time as you go down, because you can only have one y value for every x value on the function. Let's move on to actually graphing piecewise functions. So, in this first example here, we have two functions. And you have to get used to the notation here. We have two functions, y equals 2x and y equals negative x. Okay? And if you want to think about this in terms of y equals mx plus b, there's no b on this one, so the b must be 0. There's no m on this one, just a minus. Well, the m must be 1 and the b must be 0. So if you think about it, these are y equals mx plus b's, except the b is 0 on both, and one of them has a slope of negative 1, which we don't bother to write the 1. Okay, so we have this. If we were to just draw these lines, y equals 2x would look something like this, right? And y equals negative x would look something like this. And would this pass or fail the vertical line test? This would fail, because if you go straight down, you hit it twice. Boom, boom, fail, not a function. Okay? So you can't just draw the two lines. You have to look at the domain constraint. Okay, the domain is where the function lives. Okay, the domain of a line would be Africa, for instance. The domain, where this thing lives, where this thing exists. And the domain of x here, the place where x exists for the top function, is only when x is less than negative 1. And for this bottom function is only when x is greater than or equal to negative 1. So what we're going to do is the same thing we did before. We're only going to draw the function where it exists. We're going to find the endpoint or endpoints, like down here. We have two endpoints. That'll be a line segment. But if you only have one endpoint, it's going to be a ray. So these are both rays. Okay? Now, if your x is negative 1, which I gave you, what's your y? Take the negative 1, plug it in, and evaluate. 2 times negative 1 is negative 2. And that's your endpoint. Now, what does this say? Less than. That means you're going to the left. With a point and a direction, you can draw a ray. So let's come over here. Negative 1 comma negative 2. Negative 1 comma negative 2 is down here. It's an open circle. Open circle because it's not underlined. And what's the slope? Remember, this is y equals 2x. Okay? Y equals 2x plus 0. The slope is 2. So that means if I was going to the right, it'd be up 2 over 1, up 2 over 1, up 2 over 1. But I'm not going to the right, I'm going to the left. So actually this is going to be down 2, back 1. And if I had more graph, I go down 2, back 1 again. But that's it. And from here, just sketch your, if you have a ruler, great. If you don't, just do it by hand. Sketch your array. There you go. That is the top piece. Now for the bottom piece, the function is y equals negative x. So to you, that's negative 1x plus 0, right? That's your function there. Now, where's the starting point? Okay. Well, the only endpoint, or starting point as it were, is when you plug in this negative 1 here. So plug in negative 1 into negative x, you get negative 1. Let's write down the x first. So it's negative 1. And now plug this in. Negative 1 is positive 1. Okay? And this is greater than, so this is going to the right. Okay? So negative 1 comma 1 is here. Is it an open circle or a closed circle? Well, it's underlined, so it's a closed circle this time. So I'm going to come over here in negative 1 comma 1, which is right here, and put myself a closed circle right there. Okay. Now what direction am I going? I'm going to the right. And what's my slope? Well, once again, the slope is in the m spot. So this is a slope of negative 1, which means down 1 over 1, down 1 over 1, since we're going to the right here. So down 1 over 1, down 1 over 1, until you hit the edge of the graph, and then you can just draw your line. And there you go. You've just drawn your first piecewise function. Now feel free to rewind, slow me down, speed me up, whatever you want to do. This is a video, so feel free to rewind as much as you need to. All right, let's try one more here. Let's try a 3-part. That last one was a 2-piece function. Let's do a 3-piece function. So let's do what we did last time. Let's find each endpoint. Now we have 3 functions here. Okay, 1, 2, 3 pieces. We have y equals x minus 1. We have y equals 1/2 x, and we have y equals 3. Now, what's the y equals mx plus b for each of these? Well, this one doesn't have a b, so the b is 0. And this one doesn't have an mx. So you might thinking, oh, this is plus 0. No. There's no x there, which means this is actually your b. What you're missing is your mx. So this is actually y equals 0x plus 3. Now, what kind of a line has a slope of 0? It's a horizontal line. So one of the things you should be on the lookout for, y equals 3, is a horizontal line. When you have no x, you're talking about a horizontal line. Now, what's the endpoint? Let's go back to the first function here. What's the endpoint for this first function? Well, look up here. We're going to plug in a 2, the negative 2 here. Negative 2 minus 1 is negative 3. So that means your endpoint is this x, and when you plug this in, you get negative 3. There's your endpoint. What's your direction? Well, this is less than. So you're going to the left. This is underlined, so it's a closed circle. And what's the slope of this line? The slope is 1. So when you want to write it as a fraction, it's 1 over 1. All of these things are going to come in handy to help us draw our array. Okay, our array is going to start at negative 2 comma negative 3 with a closed circle. So negative 2 comma negative 3, that's right there. Closed circle, draw that first. We are going to the left, which means our slope, whatever it is going to be backwards. It's going to be the opposite of what it normally would be. The slope is usually up 1 over 1, right? So usually you'd be going up 1 over 1, up 1 over 1, and you'd be going this way. Okay, but we're not going to do that. We're going down 1 and back 1 because we're going in the opposite direction. So down 1, back 1, down 1, back 1, and there's your array. Okay, let's do the next one here. Y equals 1/2 x, or y equals 1/2 x plus 0 if you want. Well, we need our 2 endpoints. Well, I'm giving you 2 endpoints here, so you need to find 2 different points. Let's put down the parentheses here for the ordered pairs. And the first endpoint has an x of negative 2, and the second endpoint has an x of 2. What are the y's? Well, plug them in and evaluate. If you plug a negative 2 in here, what's 1/2 of negative 2? It's negative 1. And if you plug a positive 2 into this, 1/2 of positive 2 is positive 1. So here are your endpoints. Do you have to worry about left and right? No, because when you have 2 points, you just connect the dots. You don't have to worry about the slope, and you don't have to worry about the direction. Now let's just also check this out here. This is going to be an open circle. This one's open. And this one is underlined, so this is going to be closed. So that's the only thing you have to worry about, is making sure that you get that part right. So -2 comma -1. -2 comma negative is 1 right there, and we said it's an open circle, so draw your open circle. And now for 2 comma 1, that's a closed circle. So 1, 2 comma 1, closed circle. Now you have 2 points, you just connect the dots. You don't need to worry about the slope, you don't need to worry about anything. So a line segment, pretty easy, and there it is. So you have your ray, you have your segment. Let's go to the last one, which is also a ray. Now, the last one is a horizontal line, we said. The slope is 0 over 1. So don't rise at all, just run 1, all right? The y-intercept is 3. So what would be your starting point here? Well, coming back over here, this is a what here? This is a 2. And usually you take that 2 and you plug it in for x over here and you see what you get. But there's no x here, so y has to be 3. Y is always 3 no matter what the x is. So this is 2 comma 3. So go over to 2 comma 3, which is 1, 2 comma 3 right here. And this is an open circle. Okay, 2 comma 3, open circle. And which direction are we going? We're going to the right. And what's our slope? Well, we said it was horizontal. The slope is 0. So that means you're just going to go horizontally that way. And there you go. You have your 3 pieces. Now, does this pass the vertical line test? Here's our vertical line, okay? And drag it. Can I hit this more than once? No. What about here? Does that hit more than once? No, because one of them is closed and one of them is open. Now, if they were both closed circles, yes, you would fail the vertical line test. Okay, so be on the lookout for that. If you ever have 2 closed circles on the same x value, that's a problem, because that means you have 2 y values for the same x, and you can't have that. All right, keep going. This is all good, this is all good, this is all good. How about right here? Okay, same thing. One is open, one is closed. That's fine. Keep going, keep going, keep going. Okay, so for this entire graph, there's no place where you can hit twice going straight down vertically. That means this passes the vertical line test. And you should check all of your work when you do a problem on the worksheet tonight. You need to make sure that all your answers pass the vertical line test. So the key here is to, 1, find endpoints, endpoints. Find your endpoints, find your slopes, okay? Well, there's only one slope per piece, so we'll just say slope. Find your direction, okay? Less than means left, greater than means right. And then draw your piece here. Now, if you have 2 endpoints, you don't have to worry about the slope and the direction, because the truth is the endpoints will dictate, like you just connect the dots. But for the rays, yeah, you need to find an endpoint. You need to figure out, based on your slope, what your rise and run is. And then if you're going to the left, reverse that rise and run, meaning, make them both negative, so to speak. And if it's going to the right, then just follow the rise and run. All right. I mentioned evaluating functions, where you plug stuff in. When you're just a little note here. When you want to evaluate a piecewise function, you don't just plug in anywhere. You have to look at the domain constraint. So we have a function here called f of x, and this I borrowed it from the first example here. You have a function called f of x, and you want to find f of -3, meaning you want to plug -3 into this function and see what you get. Would you plug the -3 here, or would you plug the -3 here? Okay? Well, the answer to that question is, where are you in the domain? This function only exists if you're less than -1. Now let's look at a number line here. Here's 0, here's -1, here's -2, here's -3, here's +1, +2, +3. If you're at -3, you're less than -1. So you're not going to use the bottom function, okay? Because the bottom function is only for use when you're to the right of -1. So here's your -1, here's your center point here. When you're on the right here, x is greater than -1. When you're on the left, x is less than -1. Okay? Could be equal to as well, but it's not in this case. All right, so that's my point. When you have an x value and you want to plug it into a piecewise function, it has to satisfy the inequality, the domain constraint here. So check it. So this is -3. Well, -3 is going to fit into here. It's not going to fit into here. It's less than -1. It's not greater than -1. So you're going to plug the -3 into here, and you're going to get 2 times -3, which is -6, and that's your answer. How about f of 0? Is f of 0 less than -1 or greater than or equal to -1? it's definitely greater than negative 1. So you're going to plug it into the bottom one. So the bottom function is negative x, and you want to plug in a 0. You get negative 0, which is just 0. Okay. For the next one, f of negative 1. Now this one's tricky because both of these are negative 1. Which one do you plug in? Well, ask yourself a question here. Is negative 1 less than itself? Because this only works if you're less than negative 1. Is negative 1 less than negative 1? No. So you're not going to use the top. On the bottom, however, you have this equal to. See that right there? That equal to makes all the difference. So is negative 1 greater than negative 1? No. But is it equal to? Yes. So because there's an equal to there, you can plug in the negative 1, and you can only plug it into the bottom. So the bottom function is negative x. And we're going to plug in a negative 1, and we get negative negative 1, which is positive 1, and there's your answer. Okay, box your final answer. And then finally, f of 5. Well, this one's easy. Where do you plug it in? The top or the bottom? Well, 5 is not less than negative 1, so you can't use the top. 5 is definitely greater than negative 1 or equal to, so we'll plug it in here. So it's negative, and then we're putting a 5 in there. So the answer is negative 5. Okay, evaluating piecewise functions is the same as evaluating any other function, but to decide which piece to put it in, look at the inequality. Okay, if you're in a non-honors class, meaning academic class, you're done, or you can stick around for this next part. This next part is for the honors class, okay? Graphing nonlinear piecewise functions. We're going to do a little something here with a parabola in the middle. Okay, it's exactly the same idea, but you'll notice the middle function here has a squared in it. So this is going to be a ray, this is going to be a ray, but this is going to be a parabola. And how do you handle a parabola? So let's get into that. Well, the good news is that the rays are, they're no different than before. So for the ray, find your endpoint. Okay, so here we go with the checklist. Find your endpoint or endpoints. Well, there's one x value given. What's the y value? Well, plug it in to find out. Negative 2 times negative 1 is positive 2, plus 1 is 3. So there's your endpoint. What direction are we going? We're going to the left. Is this an open or closed circle? This is a closed circle. What's the slope of this ray? So your slope is negative 2 over 1. So when we come over here, negative 1 comma 3 is here. Closed circle on negative 1 comma 3, which is up here. We're going to the left this way, not this way. So that means whatever slope we have, we're going to do it backwards. So the slope is supposed to be negative 2, which means down 2 over 1, down 2 over 1, down 2 over 1, down 2 over 1. This would be the slope if you were doing it to the right, but you're going to the left. So go up 2 and back 1, okay? And that's your ray. Let me cheat a little bit. Let me go to the last part here and do this other ray, because that's the easy part, right? Let's do the ray here. So what's your starting point here? Well, you know your x is 2, because I gave you the x value there. And then you want to find the y value. So you plug in this over here. 1/2 times 2 is 1, plus 2 is 3. So there's your starting point. It's not underlined, so it's an open circle. And it says greater than, so you're going to the right. And what's the slope? The slope is 1 over 2, right there. So it's up 1 over 2, up 1 over 2, up 1 over 2. So starting at 2 comma 3, which is here, we have an open circle, and our slope is up 1 over 2. And I'm out of boxes, so that's good enough. I'll just draw my ray to the edge of the graph, and I'm done. Okay? Now, let's do the middle one. The middle one is a parabola. And the parabola, let me just move this stuff out of the way here. Let's put this over here. Put this over here. Okay, for this middle part here, you have 2 endpoints. And just like you did for the line segment, you need to find your 2 endpoints. It doesn't matter that it's a parabola. So let's do that. What are my 2 x values that I gave you here? Negative 1 and positive 2. You have the x values. I gave them to you. All right. You also know that this is an open circle and that this one is a closed circle. What are the y values? Well, plug them in. So negative 1 plugged into here. Negative 1 squared is positive 1. Positive 1 minus 2 is, minus 3 is negative 2. All right, how about 2? 2 squared is 4, minus 3 is positive 1. So those are my 2 endpoints of my parabola. Negative 1 comma negative 2 is down here, and we said this one was open. So an open circle at negative 1 comma negative 2. And then there's a closed circle at 2 comma 1, which is here. If this were a line segment, you would just connect the dots and you'd be done. Easy enough, right? Connect the dots and you're finished. However, when it's a nonlinear function, and it doesn't matter if it's a parabola or a square root function or an absolute value function or a sine function, or you can't just connect the dots unless it's linear. So in this case, it's a parabola. So what we're going to do is make a table. This is what you'll have to do for any nonlinear function. And your table will just go from here to here. Okay. Now, this is -1. So then you have 0. Then you have +1. And then you have 2. You're only going from here to here. So -1, 0, +1, 2. And you actually already know the y value for this one because you already plotted it. It's -1, -2. And you already know the y value for this one. It's 1. So what are the y values for the missing 2 parts in the center here? Plug in 0 here and see what you get. Okay, we're graphing this piece here, so we're making a table for y equals x squared minus 3. Okay, well, if you plug in a 0, it's 0 squared, which is still 0, minus 3 is -3. And if you plug in a 1, 1 squared is 1, minus 3 is -2. So that means you can now add these 2 points to your graph and you'll have a better idea of what's happening. So 0, -3 means you're down here. 1, -2 means you're here. And now you can see, can you see the parabola now? Okay, so we can go ahead and sketch in what we think the parabola looks like. Okay, and there you go. All right, that's it for today. I'll see you at the next video.